This is 2.3, solving and graphing absolute value inequalities. So the essential question, how do you solve an absolute value inequality? This is not to be confused with 2.2, which was absolute value equations. So we do equations, then inequalities. You'll notice that we're going to do that again once we get to quadratic functions. Kind of. You'll see what I mean by that. So when an inequality contains an absolute value expression, it can be written as a compound inequality. Okay, so compound inequality, that is a key term that we're going to deal with. What is a compound inequality? Okay, the inequality, absolute value of x is less than 5, describes all real numbers whose distance from 0 is less than 5 units. The solutions are all numbers between -5 and 5. So the absolute value of x is less than 5 can be written as this. This is a compound inequality. Okay, I actually do not want you to write this. So I'm showing it because it does show up every once in a while, but we're not going to use that in this class. I want to focus on compound inequality, and I call these a sandwich. Okay, it's kind of a silly thing, but you can kind of see x is in the middle of a number sandwich. So when I mention sandwiches in the notes, this is what I'm talking about. It is the compound inequality. Okay, and specifically, notice in the question, it was less than. Okay, this is when we use a compound inequality. When the problem, once the absolute value is by itself, is less than a positive number. Okay, so I'm going to write this out. This is really silly, but it makes it really easy to remember. So a less than makes a sandwich. Notice the and. Less than, I'm making up a word, less than makes a sandwich. Less than sandwich, less than sandwich. Okay, you should be able to pick that out right away. All right, so when we get into example 1, first you have to get the absolute value by itself. Be careful. Don't do anything before you do that. Okay, so I got to add 3. So the absolute value of x is less than 2. It's a positive number, so that's good. And notice the symbol, that is less than. Less than makes a sandwich. Okay, so our answer is going to be set up in a sandwich. And we can actually set up the sandwich right away. The first step is set up the sandwich. So less than sandwich, so I get -2 is less than the inside of the absolute value, which is x, is less than 2. So less than sandwich. Less than sandwich. Okay, notice it's less than less than. Okay, it should always match the symbol you were given, and there we go. But we have to solve and graph on a number line, so hopefully you remember that from the last time. Now it's where it's important. Okay, this graph helps visualize what the answer means. So we start with 0, we have -2 and +2. Now we have to be careful, open or closed dots, just like before when we talked about domain restrictions. You look at the inequality. So this does not have equals to, so it is open. And when it's a sandwich, we shade in between, meaning all possible solutions are that in between -2 and +2, I'm shading where my solutions are. So any number within this region, I can plug in and it'll work. If I plug in 1, +1, it would work. If I plug in -1, it would work. If I plug in 0, it would work. If I plug in 1.5, it would work. Okay, any number between -2 and +2, not including those numbers. Okay, so it's a visual representation of the answer. Okay. Also, we can write this using interval notation. Okay, so it's not included, so it's -2, 2. That would be interval notation. So you can technically write it either way, and I would accept it either way, but In this case, you can use inequalities or intervals. Most of the time, I make it inequality. So the next one, I'm going to look at get my absolute value by itself, which it already is, and then I look at my symbol. Once again, less than makes a sandwich. Okay, so we're going to set it up as a sandwich. -2 is less than or equal to x minus 1 is less than or equal to 2. So we set it up. That thing is in the middle with a sandwich. Okay, because remember why we're doing this, why we're making the sandwich, right? As long as the absolute value of this number, it makes this true, it can work. So anything that is above between -2 and +2, if I took the absolute value of anything between those, it would be less than or equal to 2. Okay, so we actually have to solve now though. Whenever we solve, we always do the same thing to all sides, don't just do it to one. So I needed to add 1 to get x by itself, so I got to add 1 to everything, and I get -1 is less than or equal to x is less than or equal to 3. And if you plugged in -1, it would work. If you plugged in 0, it would work. If you plugged in 1, it would work. Plug in 2, it would work. If you plug in 3, it would work. Okay, all of those make a true statement. Okay, so if we wanted to do any interval notation, this would be bracket -1 to 3 bracket. Right, hopefully that's easy. You can see it's included, all that good stuff. And then we have to graph. Okay, remember you only have to answer one of those. You do not have to answer both of those. So 0, always start with 0. -1 is closer. 3 is a little further away. This time it's included, so solid dots, shade in between. Okay, and there we have it. Last one, kind of the most complicated it's going to get right now. All right, so we have to add 6 to both sides first. We got to get the inequality or the absolute value by itself first. Absolute value by itself first, just like before when it was an equation. Divide by 3. I get the absolute value of 5x minus 5 is less than or equal to 10. So now I look at the symbol. It's less than. You make a sandwich. Once again, I know it's silly and weird, but hoping that you can remember this, how to solve these. Less than, make a sandwich. So -10 is less than or equal to 5x minus 5 is less than or equal to +10. We go through the same steps. This time I'm going to add 5 to everything first. We're solving still. So -5 is less than or equal to 5x is less than or equal to 15. And now I divide everything by 5. I get -1 is less than or equal to x is less than or equal to 3. And that's my solution. In interval notation, okay, if you want to write it in interval notation, you can always use interval notation now. We have that. And you need to make a graph. You have to make a graph. So 0, -1, 3 included, solid dots, shaded between. Okay. All right. Next, we have the next situation we're going to deal with. Okay. So the inequality x is greater than 5 describes all numbers whose distance from 0 is greater than 5 units. The solutions are all numbers less than -5 or greater than 5. The inequality absolute value of x greater than 5 can be written as the compound inequality this. Okay, so we have a different type of compound inequality now. All right, and it's an OR. So if you remember from before, we had, I should use the same colors, huh? So green to highlight my inequalities, blue to highlight my statement, what it looks like. Okay, so there we have it. X is less than -5 or x is greater than 5. Okay, Once again, I know it's silly and it's written funny, but this, how you remember this is you look at the symbol and it is great or. Great or means you need or in your answer. So less than, make a sandwich. Great or, write or. Less than, make a sandwich. Great or, write or. All right, so graph and solve, or solve and graph on the number line. Once again, first step, absolute value by itself. Okay, in this case it is. Second step, look at the inequality. So this is great or. I know it's spelled wrong. A lot of people want to point that out to me. I know it's to help you remember. Great or, right or. All right. So this is the harder one to write out. The first one is easy, right? You just kind of do the opposite, less than the inside, less than the first original. Okay. Now, when we make an opposite, we also actually have to flip the sign. So the first one looks the same. Y plus 8 is greater than or equal to 3. Or, I always write a capital just so I remember, but you don't have to. Y plus 8 is less than or equal to negative 3. Notice it switches. That's because if you change the sign, you change the inequality, which we'll talk about in a little bit when we're actually solving stuff. But it does flip. Change the sign, change the inequality. Okay, so I'm going to subtract 8 from both sides. And you get y is greater than or equal to negative 5, or when I subtract 8 from both sides here, I get y is less than or equal to negative 11. Okay, and that's my solutions. I've gotten it by itself. If we wanted to write this out in inequality notation, this one's a little bit harder. We always start with the left side, so less than is the left side. So this one's going to be negative infinity to negative 11 bracket, or negative 5 to infinity. Okay, that would be the inequality because it's less than or equal to negative 11, negative infinity to negative 11, everything less than including it, so bracket. U means or. Actually, that's where that union represents or. And then bracket negative 5 to infinity because it's everything greater than or equal to negative 5. And we can show this on a number line, so you have to graph. One of these is all you need. If you want any inequalities, that's fine. If you love interval, that's fine. Pick. Which one do you want to do? Always do that. For this, we actually have to graph. So 0, I'm noticing I'm dealing with all negatives. So negative 11 is down here. Solid dot because it's included. And I'm shading everything less than negative 11. That's to the left. Negative 5 is here. Solid dot, shading everything greater than to the right. And notice it is including the arrows. So I'm adding those things in, just signifies it keeps going both directions. Okay. Next one. Absolute value, get it by itself first. Don't forget that step. Get the absolute value by itself first. Okay. Trying to save some time so it's already solved for us. This time it's great or again. Right or, great or, right or. Less than, make a sandwich. Okay, so 5m minus 9 is greater than or equal to 24, or 5m minus 9 is less than or equal to negative 24. Okay, don't forget, if it's just less than, it's an open dot. Less than or equal to is a great dot, or a solid dot. Okay. So solving, add 9 to both sides. I'm going to try and write a little smaller here because I'm running out of room. Divided by 5, and I get m is greater than or equal to 33 over 5, or do the same thing on the one, add 9 first, So I get 5m is less than or equal to negative 15. Divide by 5. And I get m is less than or equal to negative 3. That is my first solution written in inequality. If you want, you can write it in interval, negative infinity to negative 3 bracket, u bracket 33 to 5 over 5 to infinity. There's interval. Once again, you don't have to write both, just one. Then we write the thing, the number line. So I get 0, negative 3, solid dot because it's included, shading everything below, less than negative 3. 33 over 5 is almost 7. Solid dot, shading everything above because it is greater than 33 over 5. Okay. Next. All right. Next we get into different cases. So this is when we're relating to a negative number. Just like with an equal to, you can't relate to a negative number. With an inequality, you can't relate to a negative number. But it's not always no solution. Okay, so you got to think. So it's related to a negative number, so I know I don't need to worry about sandwiches or ors. I need to just get to the answer. So I think, well, absolute value, that's going to give me a positive number. When is a positive number greater than negative 5? Okay, think about a number line. When is a positive number to the right of negative 5? Negative 5 is on the left side of a number line. A positive number is always to the right. It is always true. So all real numbers. Or if you wanted to, in inequality notation, you can write that out. Negative infinity to infinity. That's all real numbers in inequality notation. Okay, make sure you check when it's negative. So that's the first case. The other case, still related to a negative. Now I know it's going to be some positive number, because an absolute value always makes a positive number, is less than or equal to negative 5. Okay, less than or equal to. It will never be equal to, I know that, but that's not the part that matters. It's the less than or the greater than part, actually. So think where negative 5 is on a number line, and go to the left of that. Are we ever going to hit positive numbers from moving to the left down number line? Nope. So this ends up being no solution. So don't worry about the equals to piece. Look at the less than or the greater than piece. That's what matters. So if you're greater than a negative or greater than or equal to, it's all real numbers. If you're less than or equal to, it's no solution. Okay, and the last thing is dealing with negative numbers when we add or when we multiply or divide. Because if you multiply or divide by a negative, we must flip the inequality. Okay, show you what I mean by that. So on this first problem, to get rid of the negative 1/2, I'm going to multiply both sides by -2. Hopefully you know how to do that by now. You multiply by the denominator, or the reciprocal, -2 over 1. Okay, on the right, -2 times -1/2 is +1, so that goes away. We're getting the absolute value by itself. On the right, we're multiplied by a negative on both sides. We have to flip the inequality, and notice that changes a lot. So it ends up as being 20. If you don't do that, you're using the wrong thing, because if you look at this inequality, that's less than, I would make a sandwich. That's incorrect. It's greater. Because I multiplied or divided by negative, I flip the inequality. So this is greater, right or. Okay, so x plus 2 is greater than or equal to 20, or x plus 2 is less than or equal to -20. Notice whenever I write my equations, by the way, once I use the greater or the sandwich, I don't have the absolute values anymore. Don't forget about that. So subtract 2 from both sides, I get x is greater than or equal to 18, or subtract 2 both sides, and I get x is less than or equal to negative 22. Okay. Once again, you could write it in inequality. So it's negative infinity. It's negative 22 included. Included 18 to infinity. And graph the solutions. Always the same. So I have negative 22, solid dot because it's included this time, all the way down, 18, included this time, all the way up. All of my greater thans happen to be included. They're not always going to be. Make sure you understand that. Can't go over every single type of problem you might possibly see. Okay, this time I'm going to divide both sides by a negative. So we have to do the same thing. Flip the inequality. So it becomes less than or equal to. And that's negative 5. Oh, I'm relating to a negative now. So when is a positive less than a negative? Never. No solution. Okay, don't forget to look for those. Okay, and now we have to do it graphically. So the last two problems, we graph the two functions. So f of x equals absolute value of x. So that's no shift with a positive 1 slope. Remember, absolute values make a V shape. It's giving me quite a few points to follow here because we need to see the values. It goes through, boom, f of x. G of x equals 4. Y equals 4. 1, 2, 3, 4 horizontal line at 4. Okay, but it's not that simple. Now you have to really think about it. It says highlight the portion of g of x. So we're going to highlight g of x. So that's the horizontal line there. Highlight the portion of g of x where f of x is less than g of x. So we're going to highlight where f of x is below, less than, when we're talking about y values. Y values less than is down. So where is f of x below g of x? So all of these spots, notice if this is my g of x line, all of these spots, the v is below it. If I go past it, all of these spots out here, the v is above it. So I'm highlighting right there. And state the interval on the axis. So we got to pay attention to this. It is equal to, so at what x value? So 1, 2, 3, 4, and 1, 2, 3, 4. So negative 4 to 4. Negative 4 is less than or equal to x is less than or equal to 4. I know it's a sandwich because think about our number line graphs. This is kind of what it looked like, right? Where it's in between. Now solve algebraically, prove it algebraically. So absolute value, already got it. Look at the symbol. Less than, make a sandwich. Negative 4 is less than or equal. Oh, that's a mistake. That should be less than or equal to in the equation. So fix that. That should be less than or equal to in the equation. Negative 4 is less than or equal to x is less than or equal to 4. And we've proven it. Okay, now f of x, oh no, I've switched it up on you. It doesn't really matter. F of x equals negative 1, so we draw the line, horizontal line first. Doesn't matter. G of x is negative absolute value of x. So it's a V shape going down. I'm not going to draw the points because I can see already where the heck they're going to intersect. And there we have it. Now, highlight the portion of f of x, so that's the line once again, where g of x is greater than f of x. So where is g of x above f of x? Okay, so g of x is my green shape. I need that to be above f of x. All right, so where is the green V above the blue line? That section right there. That is the section we're talking about. Once again, it's inequality. It's, what is that called? Included. And so we have it. All right, so negative 1 to 1, that should be the answer I get. All right, so when I set it up, g of x, which is negative absolute value of x, greater than or equal to f of x, which is -1. A lot of people get thrown off right here. Like, well, it's the wrong symbol, right? Because that's great, or not less than. Don't forget, get the absolute value by itself first. And when I multiply or divide by negative, it flips. So now it is less than, make a sandwich. It will not always be less than. It just happens to be that twice on my examples because I wanted to kind of have a little look at flipping again and going back to the beginning of the notes, which is the less thans. All right. So that's graphing and solving absolute value inequalities. Make sure to write your 3-sentence summary.